Okay. Good evening, everyone. I am Subash Singha Roy. I am a competitive programmer. Currently, I am working as a software developer. I have recently graduated from Jalpaiguri Government Engineering College, and prior to this, I have been into competitive programming for like 4 years. So I have been participating into various programming platforms such as CodeChef and CodeForces. My max rating in CodeChef is 6 star and I am rated as 2244 there. And my max rating in CodeForces is 1935 and I am rated as a candidate master there. I have been into ACM ICPC Amritapuri regionals and there we secured a rank of around 250. Apart from this, I have also been into Code Beta Season 8 finals, that is taken by TCS, and there I secured a All India rank of 3 and a global rank of 8. So here in Unacademy, I will be teaching subjects of C++, data structures and algorithms, competitive programming, and will be doing lots of practice questions. In C++, I will be taking classes on basics of C++. In data structures and algorithms, we will be looking into various algorithms and we will also look into its space and time complexity. In competitive programming, we will be looking into various tips and tricks to increase our speed and accuracy. And practice questions, as it suggests that we will be practicing a lot of questions and the example we will be seeing today. So before moving forward, make sure you use SSROY10 code to get 10% off on any courses that you buy in Unacademy subscription. Unacademy provides various courses in its plus platform. So make sure you use SSROY10 to get flat 10% off. So before going into our lecture, let's quickly look into Relevel. So this is a platform made by Unacademy to give even chances to people who does not have a better degree or who has a poor networking over LinkedIn and other community. It may also happen that your resume does not stand out for a startup that you're applying. Maybe there are hundreds of applications and you are not the standout. And it may also happen that you have been applying to 50-60 companies, like it happens to many, like you keep on applying to 50-60 companies, but you did not hear from a single company and then you feel demotivated. So to bridge the gap, Unacademy has come with this Relevel. So what Relevel is, let's look into it. So Relevel is India's first test hiring platform by Unacademy, which helps job seekers to find their dream jobs. So basically they will be treating you on basis of your skill and talent, and it will not look your degree or your networking, right? It will be basically focusing on your skills and talents. What are the benefits? The benefits are over 50 plus companies including top startups and unicorns are affiliated to this program. There are 1,000 plus job opportunities for business development, front-end development and back-end development. Also, you can attempt this test for free. Unacademy or Relevel does not charge you a single rupee for attempting this test. And here you don't have to do the job hunting. You have to just register and all the job hunting will be done depending on your score, right? So you have to score around 70 plus to claim your profile and to get hired by the India's finest companies. So we have urban companies, Zoomcar, Cred, Kiofit, Grow and many more startups affiliated to this. So registering in Relevel is very easy. You have to first choose a test of your choice. It can be a business development test, it can be a front-end development test, or it can be a back-end development test. And after that you have to book your slot. So you have the flexibility to choose the date where you will be applying. And as you can see, you will be having jobs till 15 LPA, from 14 LPA, 15 LPA, okay? And after you book your slot here, you create a neat video resume, and after that you click on the submit button to confirm your slots. So make sure you register to the Relevel today. Also, if you are 18 plus and you have less than 3 years of experience, Relevel is the best platform to you, right? So make sure you register to Relevel today. Going forward, make sure you hit this like button and make sure you share this stream. If you share this stream, people will become more aware of what is being taught here. If you like my teaching, make sure you like this button, you hit the like button and press the notification bell so that you get notified about the next content that I'll be bringing. Also make sure to subscribe to this channel. This will help to increase the reach. So people will come to know, people will become aware that something is being taught here, right? So make sure you do that. And also there is a Telegram group. Make sure you join the Telegram group also. There it is being constantly monitored by Unacademy mentors and you can get good guidance there. So today's topic. So since we have already covered pointers, we have already covered basics of pointers, so I think we are all at the level to start our first topic, which is linked list, right? So we have done 2 classes on pointers. So I hope that whoever had zero knowledge about pointers or who already had knowledge on pointers, they all are in the same level. Now everybody knows the concept of pointers, how pointers work, what memory addresses are, and how to change values using pointers. And now we will be moving right to linked list, right? So what we'll be doing in linked list today, we'll be seeing how linked lists are represented, what linked list is, and we'll be seeing different examples of linked list, and we'll be doing lots of practice questions. So without wasting much time, let's jump into it. So yeah, let's go to the whiteboard. So today our topic is linked list. So today our topic is linked list. What linked list is, right? Now let's understand what linked list is. So we have already discussed array in our previous lecture. What did we see in the array? We saw that array had contiguous blocks of memory, right? So if we define an array, so suppose we are defining an array int a 5. So since it is int, 20 bytes, 4 into 5, 20 bytes of memory are already reserved. 20 bytes of memory are already reserved in the RAM, and 4 bytes each contiguously the variables will be getting, right? A of 0 will get 4 bytes, A of 1 will be getting 4 bytes, and so on, right? And so on. But the uniqueness of linked list is that in linked list it is not required to have a contiguous block of memory. Okay, so linked list does not have a contiguous block of memory. So one advantage of linked list over array, that is, what is the first advantage? First advantage is no contiguous blocks of memory, right? Second, what problem we have? Second problem is that if we insert in an array, what happens is that all these 3 values, suppose we are inserting in 1 to 3rd position, we are inserting in let's go to the next slide. Suppose we have this array, and we have to insert. So this is starts from 0 indexing like we have seen yesterday. So we have to insert some new value here, right? So when I insert, my array should become of 5 size. 1, 2, 3, 4. So it should be 0, 1, 2, 3, 4, 5. So it should be actually of 6 size. So initially it was a 5 size. When I insert a new array, so it is 1, 2, 4, 7, 10, right? So initially suppose the array was like this. And now we want to insert 5 in position 2. So if we want to insert 5 in position 2, we have to shift all these values by 1 each. So 10 has to come in position 5, 7 has to come in position 4, 4 has to come in position 3, and then we will insert 5 in position 2, and these 2 will remain same. So what is the worst case time complexity in inserting? It may happen that you have to insert in the 0th position. Then you have to shift all. If you have to insert in 0 position, you have to shift all values by 1 each. So what happens? Insertion here takes O of n. What is O of n? It is worst case time complexity, right? Big O, I guess you all know. So big O of n will be taking so the time complexity will be big O of n, right? So insertion in linked list is actually O of 1. Insertion in linked list is actually O of 1. You can do insertion in O of 1 if you know the location where you want to insert, right? Provided you know the location, where you have to insert, insertion is always O of 1. Insertion is always O of 1. So this is my second advantage. Insertion, deletion, these all operations are O of 1, provided we know the position, right? Next, what we'll have, so everything can see, we always use array, right? You have seen we have used array. So we will not be always having, this advantage only. It is not possible to have only advantages. So there are some disadvantages also. Right? So what are the disadvantages? So disadvantages are, one, what happens is that you need some extra memory to store the pointer. So what we know that here is a node and here we know here is a node, right? What is node I will explain, but think that suppose this is the first block where my value is stored. In array you have seen there are 5 blocks. If you make array of size 5, there are 5 blocks. So since it is contiguous, we don't have to keep track of where my next block is. Since it is contiguous in array, we don't have to keep track of where the next block is. But in linked list, since it is not contiguous, we have to keep track of where the next block is. So it takes extra memory to store the address of next node. So it takes extra memory to store address of next node, right? This is done. So this is one disadvantage. Second disadvantage, what? You cannot directly tell me what is the value of a certain position. So if a linked list is of size 5, let me take a new page. So if linked list is of size 5, 1, 2, 3, 4, 5. So if linked list is of size 5 and I say what is stored here, right? So you cannot tell me it in O of 1. So you have to iterate. In the linked list and tell me what is the value here. So searching is O of n. So what is the disadvantage? First disadvantage is we have to need extra memory, and second disadvantage is searching is O of n. Searching or getting a value of a position, not searching actually, getting a value of a position is O of n. But in array, getting a value, if I say what is the answer in position 3, you will be doing A of 2. You do A of 2 and you get the answer, right? So let's quickly discuss what is the advantage and disadvantage. So let's quickly So let's quickly summarize. So what is the advantage? Advantage is insertion and deletion is O of 1. And our size is not fixed. So here once we declare the array, our size is fixed. But in linked list, the size is not fixed. Because you can always insert an array at the end, because memory is not reserved initially. You can keep on adding nodes. So size is not fixed. And insertion and deletion in O of 1. Disadvantage, you need extra memory to store address of next node or next block, and also you need to find what is the value in a particular position. If I tell what is the value in position 2, so to do this you need to do a O of n traversal. Okay, so advantage and disadvantage is done of linked list and array. Okay, now let's understand what is a linked list, right? So I have already told you advantage and disadvantage. So now understand what is a linked list. So you may have seen me, I have drawn a node. Okay, so understand what I am drawing. Okay, so this, the diagram that I have done, so this is a famous diagram of linked list. This is a famous diagram of linked list representation. This is a famous diagram of linked list representation. Okay. Now why I have done block size. Okay. So this block, a block represents a node. We can call it a node. We can call it by any name, but for convenience, let's call it a node. So this is called a node. Okay. And this arrow is called a link. This arrow is called a link. Okay. So the block is called arrow. The block is called node and the arrow is called link. Okay. Now this block is divided into two parts. One part has data and one part has pointer to next node. One has data, one part has data and one part has pointer to next node. Now is it clear? So basically let me now elaborate one particular node. Okay, let's think that this is one node, right? So now we will be discussing a node first, right? So we have already discussed what is this. This is a linked list representation. This is a linked list representation. This is a linked list representation. These are different nodes. This is node number 1. This is node number 2. This is node number 3. Cool. Similarly 4, 5. I will tell this later. What I have written here, I will tell this later. Done. Each node has two parts, one data and one pointer to next node. This arrow is called link. Now let's look into what a node is. A node can be defined by using a structure or a class. Node can be defined by using a structure or a class. Since we will be doing functional programming, I will be preferring structure, but you can also do it by class and create objects. Okay, create objects. So class is actually a blueprint and object is the real-time entity. So that we'll cover in OOPS if you do it later on. But now we'll be doing functional programming. We'll be not using any objects or so. So we'll be using structures. Okay. Okay. Done. Now let's quickly look into how we define a structure so that we get a node. Let's do it, right? So this is basically a structured definition. We write struct node, right? Here in struct node, so this is basically prerequisite is you should know what a structure is, right? If you don't know what structure is, you go and read an article on it and it will be clear, right? There's not something hathi ghoda thing, right? It's very easy. So prerequisite is you should know structure, so this should be known by you. So what a node will have? This node will have a data. Cool. This node will have a data. Okay. The data can be anything. Data can be integer, data can be float, data can be character, data can be string, data can be anything. That is not my headache. What is data? Data is some value that we will be storing, right? Data will be some value that we will be storing, and we will have a pointer. Now why I wrote node star? Because if you remember, we are pointing to a node. And since we are pointing to a node, what will be the pointer type? Pointer type will be node star. So we will call it pointer, right? So this is our pointer. So node star type. So this is our type. And this is our pointer, right? This is our pointer, and this is the data that we are storing. Okay. And also we will have a constructor that will be of same name, right? Node. So what this constructor, what will it do? So we don't have, so why are we making a structure? So that we don't have to define it again and again. So this is kind of blueprint. We just have to pass parameter here. And so parameter will be what all data we have, that will be a parameter, and here and here and here we can initialize those parameter, initialize those data depending on the parameter. Okay, I know it is not clear. Let me make it clear again. Let me make it clear again. Let it make me clear again. So what I am telling is that, any green color? Okay, green color. So this is data. Okay, so this is data, and in constructor we will be passing all the arguments that are equivalent to data, and we will initialize it, right? So we don't have to define this node again and again. We just have to make objects. And we will pass some parameters how we want this to be initialized, how we want this data to be initialized. I will show you, and also which node it will be pointing. We can also send that, right? Or we can do it offline, right? I will show you both, right? So this is basically what node means. Right? So let's see. Where is our diagram? White or yellow or blue करते हैं. Okay, so this is done. Now we know what a node is. A node is something. A node is actually a structure. That structure has data. Data can be anything. Data can be int, string, or any data type, and it will also have a node. So it will also have a node star type of pointer that will be pointing to my next node. Okay, so you can think that here the address of this node is 501, the address of this node is something 25, some address of this node is 82, some address is 837, 43, like this, right? But we have address here. Here we have told that 25 ko point karo, right? We have already told that point to 25. We have already told that point to 82. We have already told that point to 837. So this node knows the location of next node. This node knows the location of next node. Is this clear? Okay, now let's clear the frame. So basically we have understood what linked list is, right? So we will quickly see how to print a linked list. First we will make a linked list and we will quickly see how to print a linked list. Let me clear the frame. I want all the frames cleared. Let me see. I want all the frames cleared. Okay. Are you understanding what I am saying? Let's move to coding. Right? So we'll be coding in C++. So let's write it fatafat, right? As I told, we will be doing struct node. We will be doing struct node. Then what we will be doing? We will be doing struct node, and then we will be having a data. So let's write this as, let's assume that the data is of int type. We are storing, let's store like this, right? Let's store like this. String name, int age, or okay, for the time being let's think this is only the, okay, let's not work with string for the time being. What can we do? We can do something like roll number type, right? It's best. We can do something like roll number, right? And we will be pointing to our next node. So node star next, and let's use a int roll number and node star node star. Okay, let's keep roll number for now. We will do it afterwards. So we will be to prevent your confusion, let's not use same name or you will have lots of confusion, right? We are done with structure definition. So this is a structure that I define now. This is a structure that I define now. So what we have done, this is struct node. We have sent a parameter as roll number, right? We have set a parameter as roll number. We have made a pointer of node type that will be pointing to my next node. Excuse me. So we have made a pointer of node type that will be pointing to my next node, and also we have made a constructor of node type that will be accepting a roll number, and it will initialize the object of that role to the current role that I am passing. What did I mean? Let me show you. So struct node star, suppose I am using my name Subash, and new node. Okay, let's not use name, it does not sound good. So let's write node 1, it's best. Node 1, and we are passing the roll number as 1 to this. Let's look at its value. So how to print its value? We can print its value by using arrow function, right? We can get the value by using arrow function. So actually arrow operator, you can say this as arrow operator. So or you can tell me symbol or anything you want, right? So basically let's focus on the main logic first. So you can get the data by using arrow. So you can access this, since it's a start type of pointer, since it is a start type, so actually we are pointing it. So when we are using pointer, we can access the values by using arrows. So since this is actually a pointer and it is pointing, so we have made a node type. Understand this line. So we have made a node. So we have made a structure by passing 1. So here the roll number got set to 1. And then we made a pointer which we named as node 1, and it is pointing to the structure. To get the value inside the structure, we have to use arrow operator. Right? So let's print it out so that it becomes clear. So here you can see the output is 1. Right? So if you want to understand, you can see now I have created one node 1. Let's create a new node. Now you don't have to define the structure again and again. You just have to write node 2 equal to new node 5, right? And let's print out node 2 arrow roll. So do you want some messages? Let's use some messages also so that you understand. Node 1 value, okay, and let's use a message here. Node 2 value, okay. Let's run it. So as you can see, I expect to have 1 initially and then 5, right? Node 1 has value 1 and node 2 has value 5. Now we will be linking two nodes. How will we link? So we know each node has a pointer also. So this node 1 is a pointer to this node having value 1. This node 1 is a pointer to a node that I have created that had a value 1. But this node which has a value 1 also has a node start type. Am I making sense? So let me show you in the diagram. Let me show you here. So what we have done is that we have made a node, right? Here we have assigned the value 1. We have made node 1 star and we are pointing it to this one. But remember here also we have a node start type, okay, and we have a second node and node 2 star was pointing to what was it pointing to? Okay, node 2 star was pointing to this, so here it will be 5, and this also has node star, this also has node star type, this also has node star type. Now what will we do? This we named as next, this we named as next, so this link we named as next. So what will we do? We will make sure that nodes 1 next is pointing to node 2, node 1's next is pointing to node 2. So what will we do? I am having some like no issue. Let's do it. Yeah, node 1. Okay, so what are you saying? What were you saying? Yeah, so we will be now linking node 1 arrow next, node 1 arrow next equal to node 1 arrow next equal to node 2, node 1 arrow next equal to node 2. Clear? Node 1 arrow next equal to node 2. What did we do it? We linked node 1's next, we linked node 1's next. So next was fixed, node 1's next will be pointing to next node. So this is our node 2, so node 1's next will be pointing to node 2. We have done that. Now let's see what we have done is correct or not, right? Now let's see what you have done is correct or not, right? How to know? Let's see how to know. Control C, Control V. So we have done node 1 next is now node 2, and we want its value. So how to find its value? Roll number, right? Roll number, insert. So now what we have done, we have now linked node 1 next to node 2. So node 1 next, what is this node 1 next? What is this node 1 next? This node 1's next is now node 2, and I am finding its roll number. So what do you expect here will be? Here also we should expect 5. Clear? Is it making sense? Let's check it out, right? Whether we get the right answer or not. See, we got node 2 value equal to 5. Right? So I think it is making sense. Right? So basically this is how we create a node and link it. So now you will be asking question ki can it have only one data? No, it can have more than one data. How? Let me show. Let's also use a character A or character ch equal to character ch, right? And let's pass it also char.ch. Let's pass it also, right? Let's not use the same name, or you can also use the same name. Let me show that we can use same name. Okay, ch equal to ch we can do. So this is an example where I'm using the same name. Now what you can do is that send c here and send a here. So what will we do? We will call ch here, we will call roll number here, and we will call ch here, so that we understand, right? So what I have done, first I have called node 1 ka ch, node 1 ch. So first I expect answer C, then I have called node 2's roll number, so I expect 5, and then I have asked node 1's next ch. So basically nodes 2 ch. So let's see what we have got. So we got, why is it not printing? It should print, right? Let me check. obviously we can have same name. Yeah, we are not having this. Is there some problem with the character? Let me check. Like, there should not be a problem with having same names. Let's see. Yeah, seriously, we can have problems with having same name. I don't think so. I don't think so. I think there is some problem with this compiler, or okay, for the timing let's assume that we cannot have same name, but I'm pretty sure you can use same name, or maybe maybe this compiler does not support. Depends on compiler to compiler, right? But I have already used same name, so okay, let's move on. So what we have done, let's focus on topic now. We can come back to this later. So what you can let's search it afterwards, like can we use same name or not. For the timing let's assume that same name is not allowed, right? So we have passed ch1, and we passed characters, and you can see that first we made a node having, so see, in one shot we get the data, like we get the number as well as the character. So see, we can print node 2's roll number, as well as we can also print node 2's character by using node 1. So you have seen that node 1 and node 2 is now linked. So you can see that node 1 and node 2 is now linked, right? So this is the linking that I was saying. So now I hope you understand what a node is and what linking is. So we learned linking, we learned defining a node. So we learned defining a node and we learned linking also. Right? So both is done. At the end, what we do, to mark the end of the linked list, we last point the last node, we point it as null. The last node, the next pointer, we point to null. So what will happen is that to mark the end of the linked list, the last node points to null. So once we hit the null, we will know that our linked list has over, like our linked list is done. Okay, let's now start doing some questions. So we'll be starting from basics. So I hope so linked list is clear, right? Linked list is clear. Now we will understand more by doing practice questions. So we'll be doing practice questions. So first we will be doing very basic thing. We'll be printing the linked list, right? I know it may sound very basic, but it's essential to do it initially. Then slowly we will be moving very rapidly, right? So let's first create some nodes quickly. Let's create some nodes quickly. Right? Control V. Okay. 5 nodes is good. So let's name it something. Let's name it something, and this we can give anything random. Okay, now we have to link it. Let's link it fatafat. Node 1 next equal to node 2. Node 2 next equal to node 3. Node 3 next equal to node 4. Node 4 next equal to node 5. So linking is done. And what I told, last node, we have to mark the end of the linked list. Last node next will be pointing to null. Last node next will be pointing to null. So do we write null here like this or like this? I have to see. We'll check, right? If we get a compilation error, we'll know how to write null here. Okay, so last node will be pointing to null. Done. So we have to do some iteration. Now how to iterate in a linked list, right? So we can use a while loop. So let's first use a pointer, right? So node star, this will be our iterator. So let's write a iterator, iter, and we will first point this iter to head. What is the head? Head is node 1. So we will first point the iter to node 1. Let me show with a diagram. You will be clear then. So we made 5 nodes. We made 5 nodes, right? So this was our 5 nodes, and now we are using a different iterator. I named it iter, and I am pointing it to the first node, which is node 1. I'm pointing it to the first node, which is node 1, right? Now let's run a while loop. While iter not equal to null. Why? Because we know in the end this is pointing to null. So one by one, if this iter moves, so iter moves from here to here, here to here, here to here, here to here, and then it moves to null, we know we have to stop our loop. So while iter not equal to null, we will be printing out cout iter arrow data. Data we have written here as roll number. We can also print iter arrow character, and what we have to do, we have to move the iter to iter equal to iter arrow next. Why iter arrow next? Because node 1 star was pointing to this, iter star is also pointing to this. You remember in pointer to pointer I have taught more than one pointer can point to a same node. P1 also pointing to same node, P2 also pointing to same node. So iter arrow next also means node 2. So if you don't understand this, you can follow my previous lecture. It is already uploaded in the YouTube in CodeBeyond channel. So in the same channel. Okay. So iter arrow next, and when we reach there, we are done, right? So let's see if it is printing or not. Right? Hope so. Will not have any problem with this null. Let's see. I don't know how this code compile run takes the null. Okay, we have done. Okay, so you can see 1C, 5A, 13.3, 23D, 7779, right? So you can see we have also written as this only 1C, 5A. So iteration is clear. There is also one more way to iterate, that is a recursive way. That is your homework. If you have any problem, I will explain it. So this is clear. We are iterating on okay, sorry, I thought I am writing. Yeah, so we are iterating on this linked list, and one by one I am printing its roll number, its character, and moving to the next, Okay, clear? So our printing is done, right? So next what we will be doing, we will be seeing insertion in a linked list, right? We will be doing insertion in a linked list. So next question is insertion in a linked list. How to insert interest I have written. how to insert in beginning, very beginning, in the middle, like any position, and in the end. How to insert in the beginning, how to insert in the middle, and how to insert in the end. We'll be doing this. So let's take a new node, which will be node 6. So let's comment it out. So we'll be using some node 6, right? Node 6. Node 6 equal to, let's take the value as 6 and character as D is already done, right? X. Okay, so this is my node 6. I want to insert it in the very beginning. Let's keep it. How will you understand that I have inserted? So let's keep it, right? So sorry, Control X. We'll be printing and we'll be knowing like whether it is inserted or not, right? So what we have to do? We have to insert a new node. In the linked list. So for convenience, I will be using one node and I will name it as head. I will use one node, I will make it as head, and whatever is in the first node, I will point that to its first node, right? I will point that into the first node. So I will point that into the first node. So first node was, and here I will never change it. Here iterator will always point to head arrow next, or head. It will always point to head, right? Okay. So head is pointing to node 1. So we have made one pointer which is pointing to node 1. We can do two types of thing, right? Let me explain you will understand why I am doing this. So we made a node, we made a linked list of 5. There are 5. So I am saying that I can do two ways. I can either point head here, or I can make a new node head, and its next head arrow next will always point to the first node, right? We can do two ways. Either head is always directly pointing to first node, or head arrow next is pointing directly to the first node. You can use any approach, both are correct. You can always use any approach, both are correct. So for the timing, let's use the second approach, that head arrow next points to first node always, right? So up to this, our node 1 was the first node, and we made one head node whose next always points to the first node. Whose head always points to the first node? Clear up to this? I am again repeating. So what I am doing is that I created a linked list which began with node 1. I made one head pointer whose next will point to node 1 always. Okay, that is done. Now we want this node 6. So iterator will always start from first node. We have to print first node. So first node is always head arrow next, right? Now we want to insert node 6 in the beginning. How will you do that? Let's see. So let me use some other color, white color. So this is my node 1 and this is my head. I want to insert node 6 here. What I will do? I will point node 6 next to head arrow next. I will point node 6 next to head arrow next. What is head arrow next? Head arrow next is current head, like current first node. head arrow next always points to current first node. So node 6 ka next, node arrow 6 next, I told that point to heads next. So now we are pointing to heads next. So we are now pointing to node 1. And what we do, we point heads next to node 6. Heads next to node 6. Now what happened? Heads next is now pointing to current node. So we are only making two changes. One change is that we are adding one pointer to node 1 and we are changing heads next to node 6. We are changing heads next to node 6. So two things we will do. First we will do node 6 arrow next equal to node 1. Come on bro. Head, we don't know node 1, okay? We know. So what happened is, we don't have to remember what is our first node. We know head arrow next is the current head. So we don't have to keep a headache that node 1 was first or node 2 was first. That is not our headache now. We want to insert node 6. So node 6, what will do? Node 6 next will point to head arrow next and head arrow next will point to node 6. Done. So now if I run this code, you will see that answer will be 6, 1, 5, 15, 23, 77. You will see. Node 6 will come first. Print क्यों नहीं हुआ bro? Again I am doing some ulta pulta work. Let me see what I have done. So we have, let's check it out, like let's debug it. We got some error, let's debug it. So node 6, we made a node 6. Node 6 arrow next is pointing to head arrow next and head arrow next should point to node 6. We got some iterator is pointing to head arrow next. Let's print it out, right? Let's print it out. Cout head arrow next. So let's learn debugging also here. So you saw I got some error. So let's see what error is. First we'll see the first change that we do. Do head arrow next really pointing to node 1. Let's see. So we will see roll number here. Let's print it out. We'll understand. So you can understand, we did not run it even once and we got 0. Let's see. So we got 1 here. So this is working correctly. Right? Now let's check here this is working correctly because we got 1. So we needed node 1 ka value. So we got 1. Let's check what happened here. Cout node 6 arrow next arrow roll number, right? Node 6 arrow next arrow roll number. What it gives me? It gives me 1. So we know that we have successfully done this. Now node 6 next is pointing to node 1 because we got 1. So probably we have done something wrong here. Let's see. Cout node cout head arrow next arrow roll number. We should expect here as 6. We should expect 6 here. Yeah, we are getting 6. So we have successfully done that. Then why we are getting error here? We have to think now what is happening. So we have pointing to, now we know head arrow next is our node 6. Let's check what iter has to do. Iter arrow val. Not val actually. Iter arrow roll number. Let's see what it has to do, iter arrow roll number. It is also pointing 6. Why are we getting 0 here, bro? Let me see what. Why are we getting 0 here? Everything seems correct to me. Let's check iter arrow next. Let's check iter arrow next arrow roll. We'll understand. We have to keep debugging till we don't get it right. We can't leave it here. We can't leave it here. Even if it seems correct, we can't leave it here. Let's check iter arrow next arrow roll number. See, we are getting 1 here, but in the printing we are getting 0. Did I do something wrong here, bro? So you can see 6 and 1 is connected. If we do next of next, right? So it should give me the second node. Let's check. What is happening? So see, we are getting 5. Second node had value as 5, right? Second node has value as 5. So 6, 1, 5 it is coming, right? Yeah. So why did I say 6, 1, 5? Because see, first we printed node 6, node next, right? What is the problem here? So debugging shows me it is correct. Let me check इसके अंदर घुसा भी कि नहीं. Let's check इसके अंदर घुसा भी कि नहीं. iter arrow roll number. This compiler error. Let me see what happened. We are getting 0, bhai. Okay, let's check it out. Let's check it out. You should not get this error, right? We can clearly see that our debugging is going in the right direction. Hope so I'm not making any silly mistake here. Let's check. Let's check. Let's check. What does? Okay, I have removed it. Right? Struct itr equal to head arrow next struct node star itr equal to head arrow next. I have set head arrow next as node 6. What is happening? Why is it not taking? What is happening? Let me see. See out itr arrow next arrow well oh we don't have val. What I am doing? One second, let's debug it. Bear with me. It's a good art to debug, right? We have to find out, right, what was our error. Since we are printing, everything is coming right, but we have to debug it, right? Why are you getting some error? So you can see that iter arrow next arrow roll number is giving me 1. Okay, iter arrow next arrow roll number is giving me 1. Itr arrow next, after doing if we just print iter arrow roll number is giving me. Are you seeing this? We have done iter is pointing to, we are saying iter is pointing to iter is pointing to head arrow next. So head arrow next we have fixed at 6. So we are saying that iter is pointing to this iter is pointing to this node 6. So you can see that iter arrow roll number is getting printed, but here it is getting a 0. I don't understand what is happening here. So we can come to this again later, because it's consuming our time, right? We cannot waste so much time here, but you can understand what I want to do. You can see that insertion is done in the beginning, right? You can see insertion is done in the beginning, and some issue is there. If you find it out, you can let me know, like why it is not getting printed. Like here, if you see, we are printing iter roll number, we are getting the answer, but inside when we are printing iter roll number, we are not getting the answer. So some issue is there. Let's just do some while true kind of thing. Let me see what is happening, whether we are having some, if c equal to 6 break. So this is basically debugging. I want to see whether my if condition is wrong, though it ran previously, right? Let me check. Or it will be a compiler issue, right? It will be a compiler issue. I will not use this compiler then again. Let's see. int c equal to 1 C++. Basically I am checking what is the issue. Let's see. We got a runtime error. Why? Let's print out C, right? We can get runtime error. Why are we getting runtime error? Why? They are already linked, right? We did not change it. Yeah. Strange. Initially we got 6, then 1. We got 6, then 1, then 2, 2, 3, 4, 5, 6. If 6, then we are breaking it. Okay, if 6, we are breaking it. I don't know why it is not coming up. I will pick it up in the next class then. I have to see the issue. I'll pick it up in the next class then. Let's quickly do it manually, and I will pick up this code later. I don't know why it is coming wrong. You can see our debugging is working perfectly, but something is wrong with this. For loop, I think, while loop, I think. I have to check it out. Maybe some compiler issue only, as much as I can see. If you find the error, please drop it in the comment. Let's quickly. It has taken our 10 minutes of time. Let's quickly understand. We have seen insertion in the front, right? Insertion in the front is done. We will now be looking how to insert in any position, right? We'll see how to insert in any position. Then we'll see how to insert in the back, and similar thing we'll do for deletion, and we'll close this. Session, because we have already overshooten the time. But since I have wasted some time in debugging, let us understand, right? So we have to insert it somewhere middle. So you have to insert it somewhere in the middle. Okay. So suppose we want to insert it. In this position. We have to insert it in this position. So what we have to do? We have to first iterate. So this is our head, and this is our head arrow next. This is our head arrow next. So what we have to do? We have to iterate till this position. As I have told, if I tell you insert at second position, you cannot directly go to the second position. This was a drawback of linked list. So you have to iterate till second position. So okay, we have to insert in the third position. If you have to insert in the third position, we have to iterate till second position, one position behind. Then we have to first attach this link to where node 2 was pointing. So node 2 was pointing to node 3. So what we will do, and suppose this is x node, we want to insert node x. So we will do x arrow next equal to node 3 and node 2 arrow next equal to x. So we will do node 2 arrow next equal to x. So this will delete our link, and x arrow next equal to node 3. X arrow next to node 3, it is not node 3 actually, it is node 2 arrow next. Clear? So node 2 arrow next was initially pointing to node 3. So what we did x arrow next equal to node 2 arrow next. So what happened? It directly pointed to node 3. So this is our first step. And second step, node 2 arrow next equal to x. So first we attach a link and then we detach a link. Clear? So let me first confirm that what was the error, and I will code this up quickly in the next class, right? So first understand the logic. Logic is very simple. First we attach the link, because initially if we detach the link, we will forget where node 3 is present, right? So suppose if I write this statement before, and this, if I write this statement in 1 and this statement in 2, what will happen? If we first only detach this link and attach it to node x we will have no reference to node 3. Then how I will point? If I write next node x arrow next equal to node 2 arrow next, what will happen? Node 2 arrow next now points to x, so it will point to itself only. This we do not want. So first line should be x arrow next equal to node 2 arrow next. So first attach the link and then detach the link and point it to x. Done. So this is inserting a node in between. Let me clear the frame. Next we have inserting the node in the end. Right? Similarly now we have a null here. What we can do? We have to attach a node here. So what we have to do? First attach. Same line we will write. So this is x node. This is node 2. Do x arrow next equal to. So first come to last point. First come to the last node of the linked list. How will you know it is the last node of the linked list? If iter arrow next is equal to null. If iter arrow next is equal to null, we know that iter is now standing in the last node. If iter arrow next is pointing to null, we know that iter is standing in the last node. So what we are doing? We know that now iter is standing in the last node. Suppose that is node 2. So what we will do? We will do x arrow next equal to iter arrow next. So this will be now pointing to null. And we will do iter arrow next equal to x. So this will detach and attach to this. Simple. It is clear. So we did three things. We learned insertion in the beginning, insertion in anywhere middle, and insertion in the end. Done. Now similarly we can do deletion. I will show the code in the next class. Since we have already lost some time in debugging, I don't want to waste more time. I will look where this issue came. Maybe some compiler issue, because I'm pretty sure I'm doing it correct. But I will let you know that if there is something wrong from my side, right? So now we want to delete this node. What will we do? We have to first I am first showing deletion from anywhere in the linked list, right? First we are showing deletion from anywhere in the list. So first we have to iterate and come to here. So iterate and come to here, right? Iterate and come to here. We need to delete this node. We need to delete this node. So we will be doing iterator arrow next. Iterator arrow next is pointing to this. So we will be pointing iterator arrow next equal to iterator arrow next equal to iterator arrow next iterator arrow next iterator arrow next. What we have done? We have pointed it to iterator ka next. So now it is pointing to this. Now it is pointing to this. And before that, since we do this, we lost track where this node was present, So first remove that, right? Iterator arrow next ka next point. Okay, we have to first store this somewhere. So suppose we have stored x equal to, why it is not getting written? Suppose we have written x equal to iterator arrow next. So we have this node. Now what we did iterator arrow next equal to, we can just write x arrow next. And we can do x arrow next equal to null, and then we can do free x. So free is a command that deletes it from the memory. So what we did, let me show in the next. Okay, let me show here what I did. First I want to delete this node. Okay, I want to delete this node. I came here, I stored the position, I stored the value of this node, or I stored this node in some other node. So x equal to this node. Now x is pointing to this node. I then marked iska next. I this marked node 3 next. Suppose this is node 3, node 3 next to x next. So x next was pointing to, suppose, node 5. X next was pointing to node 5. What I did node 3 is next equal to x next. So x next was pointing to node 5. Now node 3 is pointing to node 5. After that, what I did x next equal to null. So this link also deleted. What happened? First we had this link and this link. I changed this link to here and deleted this link. Now this node becomes totally free. We can write free x. And this node will be deleted from the memory, and we can see that we are pointing to next node, right? In the similar terms, if you want to delete some node in the beginning, right? If you want to delete some node in the beginning, what you can do? You can directly do. So this is our head. Head arrow next is pointing to my first node. So this is my head, and this is my first node. Suppose this is n1. So what we can do? We can do head arrow next equal to n1 ka next. Head arrow next equal to n1 ka next. First we can store it. X first. Let me write it down. Right. X equal to head arrow next. So we know first node. Now we can do what? We can do head arrow next equal to x ka next. So what happens? This node, this link that we had initially, it is cutting. We are marking this as x. So it is cutting and moving to the next node. We are doing head arrow next equal to x arrow next, and after that we will do x arrow next equal to null. So this is gone. Similarly, if we want to delete the last node, we are standing a node before. We are standing on the node before, and same thing that we did earlier, right? We have to point it to null. First we'll point it to null and then delete it. Simple as that. Making sense? We came to last node ka pehla wala node. We came to the previous node, and then and then we deleted, then we marked. First we changed this pointer to next node ka next, and we deleted it. Making sense? So simple is that if you want to delete a particular node, stand on the node before it, this node ka next, mark it. So suppose we are, let me make it very clear in one liner, let me make it one liner. What we have in one liner? Arey bhai. Okay, wait. Do we have some clear? Okay, let me clear this only. Let me make it one liner for delete and one liner for insert. Right? If you want to delete a node, if you want to delete a particular node, suppose we want to delete this node. What first action is, and suppose this is the next. Okay. First action is come here. You want to delete this node. Okay. Come here. Change this pointer to this. Once you change this pointer, come here. First store this node. Store this node somewhere. So first point, store the node you want to delete. How you will get it? You are standing here. Suppose this is iter. You get it by iter arrow next. Then you stored this node. After that, you point the previous node ka next to this node ka next. Clear? And remove this next. So this became free. When it became free, you free this memory also by using the free command. Free bracket mein x. This will be freed. Deletion is clear. Deletion and insertion is clear. Insertion, deletion is clear. So basically we have covered basics of linked list, right? We have covered basics of linked list. We know. Now let us see what we know. We know what we learned today. Let's summarize and I will close the session. Okay. Let's summarize and we'll close the session. What did we learn today? First thing we learned was advantage and disadvantage of linked list. Cool. Second, we learned how is linked list represented. Third, we learned how to iterate on linked list. So we saw that iteration was working fine. 4, we saw how to insert a node in a linked list. 5th, we saw how to delete node in the linked list, right? Insertion in front, middle, back. Middle means anywhere in the linked list. Deletion in front, middle, back. Here we are getting some issue. We saw we have inserted. We saw our debugging was running correctly, but printing was not done. So I will do some homework and come and I will see why it was wrong, whether it was some wrong from my side or it was some compiler problem. Similarly, next time I come, I will quickly wrap up this 3 topic in code and then we'll move forward with some good examples, right? We have to do some good quality question on linked list, right? So we are wrapping up for today. Hope so you liked my stream, and let's meet in the next class, and probably we will be able to debug this issue why we were not able to print it out, right? If you are able to find the issue, please drop it in the comment section so that I understand where I went wrong, right? Okay, so finally closing my stream. Make sure you like the stream if you have enjoyed till now. So basically coding is enjoyment. We should always enjoy when we code. So please share my stream so everyone comes to know that something is being taught here. And if you liked something in my content, make sure you hit the like button, right? And make sure you hit on that bell icon so that you get notified whenever my new video comes out. Okay, let's close this stream for now.